Hi, this is a video to get you started on the biology lab breeding bunnies. It's in the first unit, and it's probably the very first thing we did. And it really is about breeding bunnies. So breeders of rabbits have long been familiar with the variety of genetic traits that affect the survivability of rabbits in the wild, as well as breeding populations. One such trait is the trait for the furless rabbit, and that was first discovered in England by W. E. Castle in 1933. Since then, there's been other instances where basically a rabbit is born furless, or they have, a little bit around their face and maybe some in the ears, but not very much. They look very like those Sphinx cats or the Mexican hairless dogs. Okay, so in this lab, you will be exploring what happens to rabbits in the wild who are born with and without fur. What do you need for equipment? You need a handy dandy bag of Ziploc bingo chips. You need a plastic or styrofoam cup, and you need 3 coffee filters. Now, you need 3 of something. 3 bowls will work, 3 pieces of paper that are labeled. It doesn't matter, but you need somewhere to put your chippies. So the first thing you're going to do, it says a hypothesis is an educated guess, usually in the form of an if-then statement. Complete the following statement with your educated guess about a furless rabbit's chance of survival in Saskatchewan. And if you want, you can add the phrase in the winter. Okay. If a furless rabbit were born in Saskatchewan, then I'm not giving you all the answers, but I'm pretty sure you can figure out what can happen. Okay. So the rabbit's ability to produce fur is controlled by one gene, and there's 2 versions or 2 alleles of this gene. The one, which is represented, okay, I'm not colorblind, I know that's purple, but that's all I have with me today. So purple chips, that's the fur gene, and the pink chips is the no fur gene, or the naked gene. You need to count your baggie of bingo chips, and there should be 50 of each. If you're doing this at home, if it's not 50 of each, then just, it has to be an even number, and they have to be the same amount. So if you have 48 of the blue ones, then have 48 pink ones. If you have 46 pink ones, then have 46 blue ones. It doesn't really matter as long, don't use 10 of each. But somewhere along those, it needs to be even numbers, and they need to be the same. Okay, so if I have 45 blue ones, then just put one aside. You don't use it, go with 44, and then match it to the number of pink. So those are our 2 alleles. This one's for fur, this one's for no fur. Now, a rabbit always has 2 genes for fur. So we only have 3 different combinations. We can have a rabbit that has that, and that is going to be a rabbit that has fur. 2, I'm going to call it blue, 2 blue chips. You can have a rabbit that has a blue and a pink chip, and that will also have fur. And it's not like it's going to have less fur or shorter fur. It's going to look exactly the same. So these guys and these guys, they have the dominant gene, so they're going to look exactly the same. It's only when you have the 2 pink genes, or the 2 pink chips, that you're going to get a rabbit with no fur. Right, so explaining that. Now what you need to do is take your handy dandy coffee filters or bowls or whatever, and literally write what this says. So here is my 1, 2 capital F's. I wrote fur, 2 blue chips. So 3 things, so you know what to put everywhere. There's that one. And then it says capital F, little f, and fur, 1 blue, 1 pink. And then the last one is 2 little f's, no fur, 2 pink. All right, based on your hypothesis in question 1, what do you think is going to happen to the number of F genes as time goes on? Make your own hypothesis, but don't say they die. It's referring to the number. So the number is either going to increase, decrease, or stay the same. Those are the 3 choices. On to page 2. Right. So our handy dandy cup represents the Saskatchewan prairie, and that's where our bunny rabbits go to make babies. All of those genes represent the entire gene pool of the bunny rabbits. Give them a good shake. Have your 3 coffee filters or bowls sitting out, and without looking, you're going to pull 2 out at a time. So the first time I got 2 blue ones, so I'm going to throw that in the coffee filter that says capital F, or 2 blue. Okay, and pick the next one. Okay, 1 of each, so that goes in that one. And our third option, no, because you're not looking. All right, I got 2 blue ones, it goes in there. Here's our awkward today. We got 1 of each, goes in there. Now I've got 2 pink ones, and it goes in there. And you keep going until all the chips are in either this one, or this one. Okay, so once you've done that, then we need to do some counting. I'm going to pause this. Okay, so I paused it, and I took them pair by pair, and I've got the ones that are the blue and the pink, I've got the ones that are straight pink, and the ones that are straight blue all counted out. And put those aside. Now I'm going to turn to the back page of your lab. I'm just going to get these out of the way. And we're going to fill in the chart. Oops. There we go. I borrowed this from somewhere else, and I didn't like the chart, and I actually redid it this morning, but you guys got the original copy. But I want you to add, here we're counting pairs, and here we're counting single chips. And the reason we're counting here pairs, this says the number of capital F individuals. Well, in other words, how many capital F bunnies we have. And bunnies, an individual always has 2 genes. So here is my handy dandy pile of blue chips. And I'm just going to start counting. And I'm going to count the pairs. Oops. So 1 pair, 2 pairs, right? 2 pair, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So counting pairs, there's 32 chippies, but there are 16 pairs, and that is what I'm going to write here. Then I'm going to do the same thing with this bunch. And with these, when I'm counting, just to keep our numbers straight, you might want to be out count, because it was supposed to be 1 of each, so 1 of each pair. And I'm not going to make you watch me count. I already did the math. I counted these. There are 18 like that. And if I count the ones that are pure pink, there are 16. Now, I want to do a quick bit of math here, make sure I'm okay. 18 plus 16 plus 16 in my original generation, 50. Well, there should be, because we had 50 blue chips and we had 50 pink. $100 chips in total. And for how many pairs that's going to be, if we divide by 2, 50 pairs. It only adds up to 15 the first time, or 50 the first time. And by the way, the fact that this and this match, that was just dumb luck. So we counted by pairs. And now something sad is going to happen. Winter has come Winter is coming, isn't that what Game of Thrones said? And all of these bunnies that were represented with 2 small f's had no fur. They froze to death. So they get to go back in the plastic bag and they're dead. Put them over to the side. We don't need them anymore. So what we're going to count is the remaining ones. And I'm going to tell you a little cheat to save us some time. How many blue chips did we have to start with? 50, right? How many of those blue chips died off? None, which means we had 50 blue chips. Some of them were here. Some of them were here. But there's still 50. So the number of capital F alleles, the number of alleles for fur is 50. And throughout this whole lab, those alleles are never going to disappear. So we're just going to cheat. And we're going to write 50 all the way down. Usually I let the students figure that out, and they'll get through about 4 rounds and you're like, why are we counting those? It's the same all the time. So there's my gift to you. Blue ones are always going to be 50. What we do need to count though every round is the pink ones. So how many pink ones do I have left? 1, 2, 3, 4, 5, 6, 7. Whoops. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 pink ones. So that goes in here. And what I would suggest is actually we're going to do the first, let's do the first 5 columns first, and then I'll talk and we'll do some here. So what happens to these guys? They are still part of the breeding pool, as are these ones. So all the blue chips go back in. So right now, these, represent the dead bunny rabbits. They're out of the game. We don't need those anymore. We have all the blue chips plus the remaining pink ones. And you go through it and you do it again. So, 2 blue ones. Another 2 blue ones. 2 blue ones. Give it a better shake. 2 blue ones. Oh, there we go. Whoops. Got a blue and a pink one. And you just repeat the process. So I'm hoping this is really working and pausing words. Okay, so I went through. No more baby bunnies left. We had all the baby bunnies. And now we've got, I pulled them out as 2s. Here's all the ones that are 2 capital Fs. Okay, we have some over here that are the 2 little f's. So these are the no fur bunnies. These are the homozygous. That's the right word for 2 of the same. And we have a few down here, which are the heterozygous, so blue and pink at the same time. Save us some time. I did the counting. There were 21 ones that were pure blue. There were 8 individuals that were the pairs, 1 of each. And there were 5 over here where it was the no fur bunnies. So 5 baby bunnies had no fur. What was I going to say? No, that's good enough. All right, now winter comes. The furless bunnies die off. And now we do our count. Remember, furless bunnies dies, then you do the count. I know that there's 50 blue chips because we haven't taken any away. So really all we have to do is count the pink ones out of here. So 1, 2, 3, 4, 5, 6, 7. There it is, 8. So this time we have 8. And then this, whoops, that wasn't right, but it worked. All of those go back in there. And you keep repeating the process. You only get to stop when you get to generation 10. Okay, so you're going to keep going. I'm not going to do any more because I don't want to do the rest of the lab for you. And I'm going to remember what these numbers are. So don't start your labs with the exact same numbers as I have. Yours are going to be different. But let's finish off this side of the lab. Okay, so we have, once this part of the chart is all filled in, we can put the, yes, please. Take and put the bingo chips back in the bag. Okay, you can throw out the coffee filters, I don't care. But if you return the baggie and the coffee cup, I can use them again next year. I'm not excited about using styrofoam cups because, you know, they're not environmentally friendly. But the truth is I had a whole bunch in the class, so I'm not just going to throw them out. I'm going to use them, then we'll get rid of them. Anyway, so that stuff's done. Now we're just going to do the math. So this column says the total number of alleles. Well, we have 50 in this first row that are for fur, and we have 18 that are for no fur. So all you do is you add those together and you put that there. Now I'm going to add these together. Oopsies. Let's do the math right. That's 68. We add those together, you get 58. And again, you would just do that all the way down. Gene frequency, if you remember from the first day, gene frequency is the genes that we want out of your total. So there were, this is for the fur gene, the capital F gene, there were 50 of them. And we're going to divide that by our total here, 68. Divided by 68. All right, I'm going to say 0.74. And then for this one, it's going to be, we want the no fur gene, so it's going to be 18 out of 68 because the same total, 18 divided by 68, and you get 0.26. So round 2 decimal places. All right, I'm going to try this one. If you want to try it by yourself, go ahead and do that. And pause the video. All right, this is going to be 50, and now our grand total is 58. And I wrote that too big. And that gives me 0.86. And this is going to be 8 out of 58. And that's going to be 0.14. I'm going to check my math because that should add up to 1. So 50 divided by 58.86. Oh yeah, it does. I was looking at the wrong part. There's my answer, and there's my answer. Okay, so there you go. That's how you do the math. And once you have this all done, then you can turn around and answer all the questions here. And don't forget to answer the one up there. Okay, remember this is gene pro frequency here. So there's 3 ideas. You're talking about the number of rabbits. You're talking about the number of alleles, so this is single genes. And then you're talking about the frequency. All right, have a great day, and I hope you enjoy the lab.